Hi everyone. Um, Apologies for the delay. I had to face a medical emergency, so I could not come on time. So I'll quickly go through the questions for this week, and I'll put out the video as well as the recording, and so that the folks who have not joined can also take a look at the questions. Right. So this week, in a nutshell, if we have to look at it, we've learned about network softwareization, right? That is, it deals with how how we gradually transition from networks being a completely hardware game into something that became a more software centric aspect. Okay, for this I'll just give you a small anecdote or rather a comparative study. So um, if you look at the world of computers, if you look at the world of computers, you go and first you go and buy some hardware, right? And this hardware is nothing but a laptop or maybe a PC or something. It has no operating system. Some of them don't. Like you can have the choice, right? No operating system. It has no operating system. However, you can buy this laptop and you can install your own operating system. Right. So you can do this. Install your own operating system in your own laptop. So this is the kind of flexibility that you have. This is flexible. This is democratic. Okay. But if you have to buy some network hardware, if you have to buy some network hardware, it already has an operating system installed. It already has an operating system installed. So which means both this and this is vendor specific. So the other step of buying and installing your own software and running your own code on top of it is a luxury. So this is how the world of computers evolved. Now networks are going in the same direction where we can buy our own hardware and we can write our own code, we can compile our own code, we can push it onto that hardware so that the network device will perform the way that we want it to, or rather will process packets the way that we want it to. like some of the and, and such kind of software, such kind of hardware are called programmable data planes. Right. So this was just a small introduction to what we expect in the world of networks, or what has happened in the world of networks just in the past 10 years, or maybe we can say past 20 years, let's say. Yeah, the past 20 years. Yeah, right. So with this in mind, let's go into the questions, and I'll give you the context as and when we come into particular. Right. So this is the first question, which talks about PDUs and SDUs. Right. So if you had seen the videos, you'd know that PDU is nothing but protocol data unit. And SDU is service data unit. Now, if you look at it diagrammatically, so let's say this is layer 5, right? So you have the service data unit, SDU, for that particular layer, to which you add the header. These two together become the PDU, right? And this PDU is passed down to the next layer, layer 4, let's say. There are other layers below. So this PDU goes and sits here as the SDU, to which you add the layer 4 header, and this becomes the PDU for layer 4, and so on. So please select the correct answer on layering principle. N denotes the layer number. So layer n plus 1, which is, let's say, 5. So let's say the first option, layer 5, 5 PDU is equal to 4 SDU, right? So 5 PDU is equal to 4 SDU. Yeah, this is true. This is true. First one is correct. So 5 SDU is equal to 4 PDU. Is this equivalent to this? No, it's not equivalent. This is false. False. Similarly, this is also false. This is also false. You can take a look at it. which means the answer is A. So what does NCP stand for?
Is it network control
Oh yeah,
network control protocol? Am I audible?
yeah, yes you are, Chetan, right? Yeah,
Yes,
yeah,
yes.
yes,
Hello.
yeah.
I thought
So it
it was
is,
the network
yeah.
control protocol, but there's no option for it.
I know it actually is the network control protocol, but let me just confirm. I think the official guide is wrong. Hmm.
Okay.
Let me just verify the answer. Give me a moment. Okay, so the answer is network control protocol, right? So it's network control protocol, right? So this was the first. I mean, this is exactly what NCP stands for. But all that you also have to know is this particular statement that it is network control program was the name for the software on hosts which implemented a network control protocol of the ARPANET. So I'm not going again into the details of what ARPANET is because all that has been explained in the video. This is the first network that came up, right?
Right.
So for some of the questions like this, right, like you'll have to link somehow with the actual facts and then see which is the best option and go for it. So the answer is network control program. So yeah, so that's the answer. But you were right. Yes, it is actually. I mean, NCP should stand for network protocol, but it also stands for network control program. So sadly, yeah. But anyway, this looks weird. Clearance also looks weird. Um, um, this also looks weird because of the word problem. So I think probably you can deduct and say this is the correct answer in case such questions do come. Right. So Surf and Khan's networking principle. This was also said about in the video. So if you just look at it, then the answer is which of the following is not a part of Surf and Khan's networking principle? It doesn't talk about stateful network for effective resource sharing. Rather, at that point of time, stateful networking was not something that they had envisioned. They didn't even know that internet was going to become as big as what it is. So this was envisioned. Uniform addressing scheme was envisioned, and best effort service model was envisioned, and decentralized control and minimal autonomy was envisioned. But this was not. It should have been, but it was not. So just because of that, their initial networking principles did not contain stateful networking. So what is stateful networking? Where the network contains state, right? So if I have to give an example, a network is a distributed set of nodes. So you have all these nodes, and then you just communicate. All that it knows is it gets a packet, it checks the packet's IP address, and it sends it over here, or it sends it over here, or however it has to send it. So if the network contains some state in the sense, let's say, so much so packets have come. Let's say flow one has got 200 packets. Flow two. I told you what a flow is in the previous class. So flow is nothing but a set of packets that are bound between one destination, one source to another destination. Flow 2 has, let's say, 400 packets, or rather 4,000 packets. Then probably the network can be stateful, and it can remember that whenever flow 2 comes, you give it more priority or something like that. So this is stateful networking, where you remember certain aspects of the packets that you're seeing, and then you shape the traffic accordingly. Right? So that was not envisioned initially, but now, of course, we are going towards that. So again, there's another straightforward question, which is IMP stands for Internet Management Protocol, Interface Management Program, Interface Message Processor, Internet Message Processor. What? So Interface Message Processor, Internet Message Processor. If you know the answer, you can put it in the chat, or you can say it, or I can just breeze through it. It's very fine. You can give it a shot in the chat, but it's okay. The answer is interface message processor. So this is nothing but another equivalent of a router, but in 19, let's say 70s, I think. So this was a huge machine that looked like this, that used to connect places together. So the very first diagram in the, I think in the class that was taken would show, we'll have a picture of this IMP,
Mhm.
and it was called interface, right? Yeah. Missing something? Chetan, you were saying something, right? No?
No, no, no. I was just like nodding, saying hum.
Oh, okay. Sure. Okay,
Apologies.
cool.
Apologies.
No, absolutely no problem. Please, this is in fact, if you are here to give, if you can give me more knowledge on all these things, this is perfectly good. That's what's supposed to be. It's supposed to be a discussion session. So feel free to
Hmm.
add on to anything that I've missed out as well. So you're free to do
Okay,
that.
okay, sure. I'll try to.
Yeah, sure. Thanks. So interface message process. So this is an interface. They call it interfaces because it's all interfacing between multiple links.
Hmm.
Right? Um, so yeah, it was a big machine, and the picture is there in the video, so you can take a look at it again. If you, in case you've missed it, the very first introduction to this, I think the very first video happens. It was interface message. What are these? These are machines which um, so this is basically what are these? These are packet switching. These are the packet switching nodes. Which were used to connect networks. But when? This is for ARPANET. Somewhere around 1960s, I think, to 1989. Just the terminologies have changed. And it's basically something that we've been using here as well. I mean, but the name of router. Okay, so this must be an interesting question. Um, Yeah, so which
I think
successful
it was hello.
message? Oh, okay, so Chetan says it's hello, but I beg to differ.
Oh, okay. Was it
Yeah, so
hi?
surprise, not that also.
Oh,
So it was not hello, it was not hi. So what's left now? It's like 50-50.
login?
Things are taken off. Yep, just log in.
Oh,
So, just a fun fact here. The first message sent over, it was sent over ARPANET, and it was supposed to be login, which is what they attempted to send. But what was sent, but only LO was received, and then the system crashed.
mhm.
So anyway, this is just a trivia around that. So of course, so the following is not true about the layering principle. So layering principle is basically networks being divided into layers and governed accordingly. Right. So we have how many layers? We have 5 layers. I mean, at least in the current abstraction, we have 5 layers. I don't have to repeat what those layers are. I think you must be familiar with those. So we let's see which of the following are not true. They are not. It's not about true. They're not true. It helps for modular and hierarchical implementation of communication features. Um, this is true because layering does do that. Right? It makes it a lot more modular so that you can implement these particular functions that are attached to certain particular layers. So lower layer provides a specific set of services to the upper layers. Yes, this is also true. So you have these layers, and there are some functions here which can be called upon by the upper layer. Right? For example, if I want my message to go using TCP, I'll say use TCP protocol to the layer below. This is layer 5, this is layer 4. So this layer 4 is gonna add a TCP header to it. Right? So something like this. So it treats it like that. Protocols at a given layer communicate indirectly across adjacent nodes. Yes, so this is talking about multiple nodes here. Let's say this is a complete separate system. It's a complete separate system. This has its own layers. This has its own layers. So this particular layer communicates in a way indirectly with this particular layer only, right? So that is also true. So what is left out is this. This is basically false. But what is false here? Vertical communication does not require any mutual understanding between the different protocol layers. This is vertical communication, and this does require understanding because L5 needs to know what are all the available protocols in L4. So without that understanding, I don't know what to encapsulate this by. Right. So this communication is absolutely required. Okay. So which of the following statements is incorrect about network protocols? Now it's about network protocols. Which of these is incorrect? So they say protocols define, we'll do the same thing. We'll just go through each of these statements and then we'll see which of them are true or which of them are false. So protocols define the format of the message to be communicated. Absolutely. Absolutely. It's true. Protocols define the conventions of communication. Well, yes, that's the whole point of protocols, right? So that this node and this node can understand what they're saying to each other. It's like a language. If I know English and if you know English, you understand the words that are coming out of my mouth. But if you don't know English, then you don't even know what I'm saying. Right? That's because we previously agreed that English, in English, the word he means he, she means she, so and so. I hope you're getting it. So as long as there is an agreement where we've learned the same things, same set of rules, we can understand what's going on. What I'm sending, it can decapsulate, and it can the packet can be decapsulated, and it knows which byte number means which protocol or what it means in the packet that it's receiving. So that's the conventions for communication. Right? So all the network protocols have to be accepted and published by standard organizations like IETF. But this is actually false. It's not completely required that this be the case. It is not really required. And all of them have to be done because you basically can create your own network protocol and you can run it. And these are proprietary protocols. You see Skype, they have their own proprietary protocol, which we don't know how they do it, but they do it basically. Only some companies come out and give out their protocols and then maybe open source so that everybody can understand. But most of them don't have. Right? Um, Protocols define the procedure and sequence used to exchange messages. This is also true. If anything is a bit unclear, you can ask me. Right? So, which of the following is not a characteristic of a middle box? So, what is a middle box? So, a middle box is basically a node in the sea of nodes, in the sea of network devices. It's basically a network device, let's say, right? The network device, which essentially does more than just routing. Right? So, for example, these could be something like, let's say, in between this route, these are all routers, and let's say in between these two routers, I have a firewall here. That's a middle box. That's in the middle of the network, right? So, and this middle box could do many things, or rather, you could also have a NAT, network address translator. This is also a middle box. So, officially, if you ask for the definition, it is an intermediary device that performs functions other than the normal standard functions of an IP router. Right? What does an IP router do? It does routing. That's why I said routing. But yeah, so this is the formal definition of a middle box. Maybe I should write it down. So
So I would like to ask something here. If a router has some features like quality of service and all that, so in
right.
that case, would that be counted as a middle box?
E- um, so those are middle box functions. So okay, quality of service is also, let's say, routing associated, but again the lines are quite blurred. So if you buy a particular piece of equipment and that is not labeled as a router, so the main function of your device is routing. So of course you have added functionality like this, which is blurring the lines. So you could also say it's a router come slash slightly a middle box, but mainly your the main function of your device is to compare your packets, header fields, and then send the packets on their way. That's what a router does
Okay.
mainly. So
Right.
again, it's a very blurred line. Um, so it's like an 80 percentage router and 20 percentage middle box. But if the roles are flipped, right, 80 percentage it is doing these other jobs, and then only 20 percentage is doing routing, then you can call it a complete middle box. So that's it.
Okay. Thank you.
Yeah, and even if you don't, in fact, your own router also has some firewall functionalities. Have you noticed? It could.
It has ACLs, right?
It has.
Like router, I believe they can have ACL, access control
Yeah,
lists.
yeah, exactly. Access control list, exactly. So that's also something like a firewall only. You can use that as a firewall. You can also function. You can also filter out some keywords and add parental controls. and so and so. So, but yeah, again, the lines are blurred here. That's but those are actually middle box functions only. So yeah, standard function. So as per this definition, you're deviating from the normal standard functions of an IP router. So I think nowadays an IP router is basically something that does mostly routing plus some of these other aspects. So they are clubbing that also along with it. So it's supposed to be called a router. So it'll be called a mailbox when it does complete more of anything other than routing. Right? So anyway, so the following is not a characteristic. So intermediary device placed between source and destination host. This is a characteristic. So this is true. So perform IP routing and forwarding functions. This is exactly what it's not supposed to do. I mean, rather it doesn't have to do it majorly
mm,
and perform non-standard networking functions. This is also something that a middle box does. So this is true. It typically includes stateful networking functions. This is also true. Stateful. I told you what stateful means. So it has to remember some state to take care of it. Firewall also has to remember state. It needs some let's say ACL rules, and then maybe it has to see how many of these packets have been blocked. So it remembers some state about these flows. So this is true, 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 and false. The answer is B. So this is the answer. And here the answer is this. So you must have seen internet ossification, right? So ossification is something. It's basically called. It's like something that's calcified, something that has become more set in its own ways that it's unwilling to change. Right? So the internet evolved, and sadly, we went all in on some protocols and designed the internet in a particular way. Now, if you want to change everything, you have to change. You want to change some things, you have to change everything across the internet. That's a problem, right? You have to change the hardware, you have to change the understanding, you have to change all those. So, which of the following aspects is not the reason for the internet ossification? So, why did this happen? Let's look at it. So, evolution of newer internet technologies. Is that a reason for internet? Okay, so basically, okay, we have to see reasons for internet ossification. So newer technologies, of course, they developed, and in fact, the newer technology is the reason why we are blaming internet ossification, why we know that internet has ossified. So the answer is this. So this is not true. So this is the correct answer.
mm,
And widespread adoption of TCP, IP stack, and socket APIs. So this is a reason that contributes to ossification, right? Whereas point one, point A, these newer technologies do not cause ossification; they try to solve it. So basically, I'll just give you the definition of internet ossification. It refers to the difficulty of changing internet protocols due to legacy dependencies. This is the official definition, but we don't have to go into those nuances if you understand what this means. So widespread adoption of TCP/IP stack and socket APIs. So this is true. Competing interests of the stakeholder. So this is also true. I mean, in the sense that you have many stakeholders. Who are the stakeholders? Stakeholders are people who provide these internet devices. They are the biggest stakeholders. And you have Cisco, you have Juniper, you have all these different companies which create their own kind of devices and they put it on the internet. So if you change a protocol in one of these companies, let's say Cisco, then Juniper is not going to be happy with it. So they'll come up with their own version of it and call it something else and implement it. So you want to change something radically across all of these devices, right? You just can't. You can't wake up one day and then say I'm implementing something new in this protocol and then it has to work on the internet. It's just not going to do that. It's a proliferation of various middle box and networks. So this is also true because middle boxes, what do they work on? They work on the existing protocols, whatever we are expected to see in the packets. So if you're going to change something, if you're going to change a particular protocol, then all these middle boxes will break because all of these middle boxes or routers or these network devices, they are highly tied. They are linked to their hardware capabilities of network processing. It's not software, it's mostly hardware because you need to process packets at a very high rate. Right, so which is why changing these are not going to be easy. And so again, the answer to this question is A. I'm just giving you context as we go along. If you've seen the video, you'll understand what I'm speaking. If you've not seen the video, you might not understand. So go and see the video and then come back and listen to this when the recording is posted online. Right? Okay. Mm, hmm. Okay. Is it C? Or I'm just seeing the message now. Rashmi is put. Is it C? C is for question number 10. I don't know which one it was that you said. I'm sorry, I didn't see that. Right. So question number 10 is which of the following is not a solution to break the internet impasse? The following is not the solution, right? Um, so internet impasse, right? So we saw what internet ossification was. So internet impasse is it refers to the difficulty for innovation. So in a way, it is connected to this. Uh, Internet impasse is an outcome of internet ossification. Right, so by innovation, what do we mean? Simply put, if I want to use a new protocol, how will I test it at a large scale? You think this is easy, but you can simulate, but you never know the actual performance when it comes to the hardware, the real time peaks of traffic as to how your protocol is going to work. So the following is not a solution to break the internet impasse. So what is the solution here? So we will see all these things in the future classes. For now, just take it with a pinch of salt. So network virtualization, this is a solution. SDN is also a solution. Overlay networks is also a solution. But network address translation is not a solution. NAT. You must have seen you must have studied what NAT does. It converts a public to a private IP. Sorry, it converts a. I think it does the both basically. Private to a public IP. So this is nothing but a middle box function. So it does nothing to help grow innovation in network. The answer is A. And if you don't know any of these terms that I'm talking about, please feel free to ask or message on the chat. I'll be able to explain to you what I'm talking about as well. Right. So we'll move on to the next set of questions. Oh, question 5. So which means I had seen it very long time ago. I mean, I didn't, you had posted very long time ago. That's fine. That's all right. So what does IMP stand for? So I think you should know this by now because it's a repeat question basically. Interface message processor, right? I mean, I'm just breaking through that because we already discussed that and that was the established answer. So, which of the following is considered the world's first operational packet switching network protocol? So again, this is also a repeat question, but in a different format. So the world's first packet switching network protocol was Network Control Protocol. UDP is recent, TCP is also recent. This is TCP, this is UDP. IP is also recent. So if the key is world's first operational packet, so it's like NCP, and this has happened for ARPANET. The first internet message was exchanged between the following stations. Which are the following stations? This was also spelled out in the videos, not exactly written on the slides. So the answer is UCLA and Stanford Research Institute. Right? So UCLA is University of California, Los Angeles to SRA, and this was using ARPANET in 1969. Okay, and why the other options are incorrect? Because they are not UCLA and SRA, right? So the answer is A. So we saw SDUs and PDUs in the first set of questions. So what is layer 4? Layer 4 is transport, right? So layer 4 is transport layer. So layer 4's PDU is equivalent to the whatever it received from the application layer plus its header. So basically it's what is going to be passed down to layer 3. And so what is that called?
Segment.
Yes, it's called a segment. Right. Answer is B, segment. These are very straightforward questions, so not much to discuss here. So again, another question that's similar. Uh, I mean, this is a similar model, let's say. Right? The PDU of layer n is equivalent to. I'll give you time to look at it. Let's see if you can get the answer to this.
Uh, is it C?
Okay, C is also right, but yeah, okay. There are multiple answers to this question. It's a multiple answer question. Okay, so let's look at the first one. SDU of so PDU of layer n. Let's say layer n here is 4. Okay, let's take it as 4. So we're looking at this layer. So PDU of layer n, which is this, right? Which is this one. They're asking what is this equivalent to, right? It's equivalent to SDU of layer n plus 1. Is it equivalent to this? No, this is not. So this is false. Is it equal to SDU of layer n minus 1? Yes, this is true. So this is true. So, and obviously layer n header which is, so I'm looking at option number three. So layer three header plus SDU of layer n. So they're talking about this whole thing right now. This is also true, and that is what Chetan had said. And is D correct now? So layer n header. Oh, sorry. Hmm. Option three talks about this layer n header and SDU of layer n, right? And option four talks about same header but PDU of layer n plus one. So in a way, this translates to this, and this translates to this, and this translates to this. So this is also right. So I hope you understood this one. Just draw this diagram and you can easily figure it out. It's just like transitive property here. Right. Okay. So which of the following statements is slash are correct about horizontal communication in layered architecture? So this is horizontal communication. Right? So horizontal communication is not vertical, it's horizontal. So you have multiple nodes like this. Each of them have layers. There's communication between this layer and this layer between across multiple nodes. Okay. So does it is they're asking which of them are correct, which of them are true, right? So it represents a peer-to-peer layer communication model. Yes, it does. It's true. It's peer-to-peer. And the mode of communication between peers is indirect or virtual, which means there is an indirect communication between these peers across these multiple layers. And I think that's how you're supposed to take this. It's an indirect. I think we saw a similar question above as well. This is also true. It requires full knowledge of the vertical layers that communicates with each other. No, it doesn't require full knowledge. It requires partial knowledge, not complete knowledge. This is false. And none of the above. This is also false. So first two are the answer. Right? Okay. Again, it's about Cerf and Khan's networking principles. Which of these do not adhere to it? Best effort service, it is true. Circuit switching with resource prioritization, no, this was not said. This is false. Decentralized control, this is also true. This was also said in certain Khan's principles. And guaranteed delay, false. There is no guaranteed delay here. We are not saying that this has to be sent within 5 milliseconds or 10 milliseconds. Internet cannot do that. Even now, you cannot guarantee delays. It is a very highly fault tolerant network. So the answer to the above ones are this and this. So which of the following is slash are true about end-to-end principle, right? So end-to-end principle. So the answers for this is for correct operation the network. must be stateless. Okay, I'm just giving you the answer and then I'll explain what this is. So this is true. And C, intelligence about the service slash function must only be at the endpoints. This is also true. So what is wrong here? It does not. It need not be stateful at both endpoints and the network. So essentially, what this says is this is you here, and you're trying to send something to someone in a remote location. Let's say over here, right? And then you have a network that has to go through something like this, this, something like this. It's a huge network, right? So they are basically saying this is one end and this is the other end. Right? Once you send a packet, once you create your packet and then you put it on the network, you have no control over it. And that's why the intelligence, the core intelligence about how this packet is going to be used only resides here and here. The rest of these nodes here, their only job is to see the information that they've given and route it across. Right? So this principle basically it's just a design principle which gives complete power to the end or edge or the originator and the sender. Right? So the answer is B and C here. Right? And this is under this principle it must be stateless. But if you see current internet, it's not completely stateless, right? It's some stateful factors also there. It's just another principle that was developed in the course of the internet's evolution. It was not completely implemented. No. Right? So this was directly from the video. Um, so the robustness principle, uh, it basically means that networks must be designed to be interoperable. The answer. So you have, so when I showed you this diagram, this is one network, this is another network, and these networks can communicate amongst each other, right? So, and that's what this means. Robust. It should be robust enough to be interoperable. Which of the following statements are true about network ossification? The last question for today, I'll just leave it to you. You can answer. I'll give you the answer in like 2 minutes, right? So as networks grow, they become more resistant to change. Yes, this is true. Ossification hinders the prospects of innovation. Yes, we just saw this is true. Provides impetus to a competitive market. No, this is not true. Ossification doesn't provide a competitive market. It encourages monopoly. This is false. No, this is also false. So the answer is A and B, right? So I think yeah, this brings us to the end of today's session. Yeah, I think there's nothing more here. And if you have any questions, you can ask on the chat. I'll be here for like another 5 minutes, and I'll end the call at the end of 5 minutes. You're free to leave if you are if you don't have any questions. Right? Thank you, guys.
Thank you, Harish. Thank you for the session.
Yeah, sure, sure.
Will
Thank
you
you.
be taking one next week also, next Tuesday?
Yeah, yeah. Every week I'll be taking at the same time. Like today I
Okay,
was a bit
okay.
delayed and I have a health issue.
Mm-hmm.
Probably next week I'll be there like half an hour early. Right. Okay.
Okay, okay. Good. Okay. Take care. Thank you.
Sure. Thanks.
Bye.